Last but not least is the negative exponent rule. So we've gone through 4 rules already of exponents: product rule, power rule, quotient rule, zero exponent rule, and the last but not least is negative exponent rule. Sorry, number 4 is zero exponent rule. So the negative exponent rule, basically in all of these problems, the direction will always say that you always want to give final answers with positive exponents only. So you always want to give an answer with positive exponents. You cannot leave them negative, right? So that's why it's called negative exponent rule, meaning you always give final answers with positive exponents only. So how do you change a negative exponent to a positive exponent? So here's the rule. The rule is this. If I had any number or letter raised to a negative exponent, how you make it positive is basically you flip this upside down. You flip the A upside down. So if you kind of think of this as A over 1, right? It's a whole number or whatever, A over 1. If you flip it upside down, you get 1 over A. So that becomes 1 over A to the m power. So that's how you make something negative into something positive. So here in number 11, I have 5 to the negative 2. So again, I see a negative exponent. How do I make this positive? I flip the 5. So the base is 5. I flip it upside down. It's 5 over 1 right now. So when I flip it upside down, it becomes 1 over 5. The negative 2 now becomes a positive 2. And as a result, 1 over 5 squared becomes 25. Now, same story with when you have a fraction. So when you have a fraction here, 3/5 to the negative 1, all you need to do, since you see a negative exponent, all you do is you flip the inside and you get 5 over 3. And now to the positive 1. So this is a positive 1 and positive 1. It's applied to everything inside. Well, positive 1, so you end up just getting 5/3. Question number 13. Negative 6 to the negative 1. Again, I see a negative exponent. Because it's a negative exponent, this negative 6, I'm going to flip it upside down, and I get 1 over negative 6. Note, I do not change the base. So do not change the sign of the base. So the base sign stays exactly the same. The only sign that changes is the exponent. The negative 1 now becomes a positive 1. So I have negative 6 raised to the positive 1 power, which is just negative 6 on the bottom. So 1 over negative 6. Of course, you could write this as negative 1 over 6. It doesn't matter where you put the negative when you put down your final answer. Now, let's take a look at the problems that we had done a little bit earlier where I said I'll get back to it. Let's look at number 8 and number 9, where we had the answer 2/3 w to the negative 2. Well, now we know what to do with this negative exponent. This w to the negative 2, in order to make this a positive 2, I need to bring the w. So since w negative 2 is on top, all I need to do to make it positive is I bring the w downstairs. So my final answer for this problem would be 2/3. W negative 2 was on top earlier. Because it's negative, I want to make it positive, so I bring it downstairs. So in other words, I'm just flipping it to, it was in the numerator, now it's going to become in the denominator. So we have 2/3 w squared. So this becomes the final answer for number 8. Number 9 that we did earlier, we got this answer, but we had a negative a to the negative 4. How do you make the negative 4 become a positive 4? You bring the a downstairs. So again, it's like you flip it. So the a to the negative 4 will go downstairs. So your final answer is going to become 9 over 16, a to the 4th, b to the 4th. Or you could have written b to the 4th, a to the 4th. It doesn't matter the order. But the point is that the negative 4 now becomes a positive 4, and now your answer is only with positive exponents.